Here is assignment 1-3. I don't even know if you, does it really matter if you see my face or not? I don't know what happened. I'm just going to do it. I don't know where my face went. I don't think it matters. Assignment 1-3. So, here's assignment 1-3. Use the graphs to find these limits and answer it as either infinity or negative infinity. All right. So for number 1, the question is, find the limit as x approaches 2 to the left of 1 over x minus 2 squared. So 2 to the left, here's 2. To the left, the answer is infinity. That's A. B, the limit as x approaches 2 from the right. So if I look on the right, it's the same answer. It's also infinity. Number 2, the limit as x approaches 2 from the left of 1 over x minus 2. And you might as well do the other one right away. The limit as x approaches 2 from the right of the same function. So in other words, if I look from the left, where is it going? So here's the graph. From the left, it's going to negative infinity. And on the right, it's going to positive infinity. Number 3. The question is to find the vertical asymptotes and then label them as odd or even. So something that's non-removable in the denominator, what value makes this 0 on the bottom? So that answer is 0. And is it an even or an odd exponent? So it's an even asymptote. Number 4. So first you look, is it removable? And then once it's removable, it creates a hole. So the x is removable. So what's left, what makes this 0 is positive 1. And what's the exponent? It's even, so it's an even vertical asymptote. Number 5. F at x equals x over x squared minus 4. We need to factor this, difference of squares. Nothing is removable, so both of these are asymptotes. Positive and negative 2. Both have odd exponents that you can't see, so they both are odd. Number 6. Now I'm going to factor it right away. So the two numbers that factor are negative 2 and positive 1. Nothing's removable. So the vertical asymptotes are at positive 2 and at negative 1. Both have odd exponents that you don't see, so these are odd vertical asymptotes. Number 7. I'm going to factor it. It's a difference of cubes, so this is how it factors. It's x minus 1, x squared plus x plus 1. I know. It happens. So recognize that after you factor it, it's removable. There is nothing left in the denominator to create a vertical asymptote, so there are no vertical asymptotes in number 7. Number 8. Ooh, tricky one. Trigonometry. Beautiful. So where are the vertical asymptotes here? Let's just do a quick little lesson here. When you graph, it's where it's undefined. Cosecant is the y value. Here's the unit circle. So we're looking for the y value that is 0 because the reciprocal of 0 is undefined. So the y values where 0 would be 0 and pi and 2 pi and 3 pi, so on. So at every multiple of pi. Or really it's x, right? Because pi is already there. So at every integer. And they're all odd. They go up in one direction with the exponent and down the other way. Number 9. We have the limit as x approaches 3 from the left. They say don't say it doesn't exist. Use infinity or negative infinity. So if I look at 3, it's an asymptote, so it could not exist. But from the left, pick a number smaller than 3. So positive 2 gives you a negative answer, so it goes to negative infinity. That's just a quick check, an easy way to do it. If it's not one-sided, and they go, like this is an odd vertical asymptote. It goes up in one way and down the other way. It's not removable. So this one doesn't exist because they don't go in the same direction and it's not one-sided. Number 11, the limit as x approaches 1 from the right. I'm going to factor it right away. So if I factor it, I can remove, and then what's left over, 1 is a vertical asymptote. It's odd. From the right, pick a number bigger than 1, and that's a positive answer, so it's going to positive infinity. Number 12. The limit as x approaches 0. Again, I'm going to factor this. This is the same one, right? So I want you to notice that you can remove the discontinuity. You can now plug in 0, and you get 1 divided by negative 1, and you get an answer. So there's no asymptote after you remove it. Number 13. The limit as x approaches 3. I'm just going to factor it right away. So two numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. I want you to notice that really that's negative 3 squared. And because it's an even one, they both are going the same direction. So if you square it, so let me write it down squared so you can see it. Anyways, if you square it, the answer is always going to be positive around 3. So when you square a number, so on both sides, it's going to infinity. So again, the best way to tell, plug in 4, plug in 2, and recognize you're going to get a positive answer both ways. So both sides are going to positive infinity. It's an even exponent, so they're going in the same direction. The limit as x approaches 3. Oh, same thing, right? Oh, x minus 3. Now, for this one, we'll write it like this. Now, notice it gets removed, but when I plug in, it's undefined. So this one doesn't exist. So even though you can remove 1, you can't remove both. And when you plug in 3, that's undefined, and that doesn't exist. Number 15. In number 15, the limit as x approaches 0, we're going to factor it right away. That's x minus 2 over x cubed. Recognize that this reduces down to just x squared, but when I plug in 0, it's undefined, but it's an even exponent, so both ends are going the same way. So if you plug in positive 1 or negative 1, you get a negative answer. So both ends are going to negative infinity. Number 16, the limit as x approaches 0 from the left. So we have an odd asymptote here. So if I plug in a negative number to the left of 0, I get a negative answer. That's negative infinity. Number 17. Oh, trigonometry. So the limit as x approaches pi over 2 from the right. So if I plug in pi over 2, I get 0, the value of cosine that's at the top of the unit circle. So it is undefined, but from the right, it's going to negative infinity, right? Yeah. So from the right means here's pi over 2. And if you from the right, you pick a value, an angle in quadrant number 2. And if you go to quadrant number 2, cosine is negative in quadrant number 2. So from the right, it's negative. From the left, it wouldn't be. Oh, look at that. That's like Minnie Mouse. 18. I'm so happy. The limit as x approaches pi of x over cosecant x. So recognize that the answer is 0, actually undefined there. We could actually write cosecant as the limit as x approaches pi the reciprocal of cosecant split up is sine. So we could actually write it like this. And then when I plug in pi, the value of sine at pi is 0 times pi, which is 0. Pretty tricky, right? In terms of it. Need to know some trig identities there. Number 19. Find these limits without using a calculator. So it gives you a graph, which is nice, and an equation. So what's the limit as x approaches infinity of f at x? This is power term over power term. So the power term on top and the power term on the bottom divided out, and the right end behavior is going to 2. That's the same for the left end behavior too, and you could see that on the graph. So even though it wasn't labeled, when you go power divided by power, that asymptote goes through 2, both left and right side. Oops, positive 2. That creates a horizontal asymptote. That's what it is on both sides. Number 20. For number 20, again, we're trying to find the end behavior. So let me just talk you through it and then we'll write down the answer. So the end behavior, when the bottom is more powerful, both ends are going to 0, as you can tell. Here, we have 2 asymptotes. So when I go power divided by power, this creates a positive and a negative. So when I do it, this is positive 2, and on the other side is negative 2. Let me just write that out. I'll make it simple for you. So this is 0, and this is 0, and for 21, this is 2, and this is negative 2. I won't make you write it up more than that. 22. For 22, we're talking about end behavior. That's power term over power term. So power over power, that's 2/3 when you divide out the x, and you're done. Let it be simple. Again, power over power. Just be careful that you know what the power terms are. So the most powerful term divided by the most powerful term, the x cubes divide out, and you're left with negative 1/2. 24. This one's more challenging because you got to multiply it out. So 2x squared is 4x squared times x. Here, x squared times 3x. That's 3x cubed, and then divide it out, and you get 4/3. You just got to be careful of the exponent when you multiply it out. 25. In number 25, the limit as x approaches infinity of x times 2x minus 1. Isn't that the same one? I'm writing down the wrong one. All right, let's try it again. So the limit as x approaches negative infinity, 4x squared plus 3 over 2x. So if I go power over power, the top is more powerful. So if I divide that out, I get 2x. So the left end behavior, this 2x is a line in this direction. So the left end behavior is going to negative infinity, and the right end behavior is going to positive infinity. 26. The limit as x approaches negative infinity, x divided by the square root of x squared plus x. So be careful here. So this creates 2 asymptotes. That's positive or negative x. So that's positive or negative 1. So to the left, this is negative infinity. The answer is negative 1. And to the right, it would be positive 1. 27. Same question, but to the right. So the answer is positive 1. 28. The limit as x approaches negative infinity 2 subtract x, square root of x squared minus 3. Careful here. So we have negative x over positive and negative x. So we still get positive and negative 1, but because it's negative x on top, the right end is going to negative 1, and the left end is going to positive 1. So be careful you know the signs. So that negative x means it's going to negative 1 on the right, and then it's positive 1 on the left. 29. The limit as x approaches negative infinity. 2x squared minus 2 over the square root of x to the fourth. So we have 2x squared. The square root of this is positive and negative x squared. So this divides out to this. Because it's positive in the numerator, the right end goes to positive 2 and the left side goes to negative 2. $30. Oh, if I put in a positive number or negative, yeah, because it's positive over a positive or positive over a negative. Yeah. Okay. Sin x over x plus 1. So power over power, and that's going to end up where when I look at it. So sine x is more powerful than just x. So when the top is more powerful, the end behavior is 0. For 31, I'm sorry, the bottom is more powerful than the top. So as the numbers get bigger, x will keep getting bigger, but sine will stay between negative 1 and 1. So because the bottom is more powerful, it's going to 0. All right, we need a calculator. Let's type this in. So the limit as x approaches infinity, and it's x to the fifth, e to the negative x plus 2. Let's see if we can use our calculator. Where the heck is mine? Here it is. All right, let's type this in. So we're going to press menu. We're going to go to calculus. And we're going to go to limit. If it goes too fast, you press pause. X to, now to find infinity, see this in blue right here? So go control and that, and then you can find it. There it is. So as x approaches infinity, and then we can type in x to the fifth, move the cursor, e, make sure it's this e, not the e in the bottom. So e to the negative x. That'll clear up in a second, hopefully. There it is. Oh, I had it and then I messed it up. There we go. Move the cursor. Plus 2. All right. And you get the answer 2. For number 32, using a calculator, you try it. The limit as x approaches negative infinity. The absolute value of 2x plus 5 over x minus 7. All right, menu, calculus, limit as x approaches infinity, or negative infinity. And it's a fraction. Absolute value bars. 2x plus 5. Move the cursor. X subtract 7. And you get negative 2. $33. Now we're doing some graphing. F at x equals x plus 2, x minus 1 squared. So it says list intercepts, asymptotes, whole, behavior, and so on. This is a polynomial, so there's no asymptotes or holes or anything. We do have a x-intercept at -2, and it's odd, and at +1, and it's even. We also have a y-intercept. If I plug in 0 for x, it's -1 squared, which is 1 times 2. And now we could graph it. Know the end behavior. So the end behavior here is x times x squared. It's x cubed. So the right end goes up and the left end goes down. And then just connect the dots, and there you have it. Number 34. Let's see if we can practice this. The numerator, there's nothing that simplifies, there's no hole. The numerator gives me +2 with an odd exponent. The denominator gives me the vertical asymptote, which is -2, and again with an odd exponent. The y-intercept is put in 0 for x, -2 divided by 2. And then the end behavior, which is really the horizontal asymptote, power over power, and you get x divided by x, which is 1. So we'll start there. At 1, we have a horizontal asymptote. At -2, we have a vertical asymptote. We have intercepts at +2 and at -1. So this is what the picture is going to look like here, and this is what the picture is going to look like here. Recognize it crosses at that. Recognize it's an odd vertical, so on one end it goes down and the other end up. And then the end behavior, what I'm looking for. 35. We have f at x equals x times x minus 1 cubed, x squared over x minus 1. So we're going to simplify it. So x makes x squared just an x. X minus 1 makes this x minus 1 squared. So a few different things here. The domain x cannot equal 0 or 1. Recognize that x minus 1 was removed. So there's a hole in the graph at +1. If I plug in +1, I get the answer 0, and it has an even exponent, so it's even. The vertical asymptote is 0. It has an odd exponent, so it's odd. X-intercept, so +1 ended up being a hole, so there's no x-intercept. The y-intercept, if I plug in 0 for x, it's undefined, so there's no y-intercept. And the end behavior. So if I go power over power, that's x squared over x, or x. So it's going to have end behavior up to the right and down to the left. So if I graph this, we can start at 1, 0, and we can also have a vertical asymptote at 0, and the end behavior going up to the right and down to the left. It's going to touch here. So it's going to do that. And then the asymptote is odd, so if it goes up to here, it goes down the other way. And then the end behavior, and it has it. I know, the more you practice, trust me, the easier it does get. 36. All right, how do I graph this? The domain, let's talk about the domain. X has to be greater than 0. Any negative numbers would be imaginary, and 0 would be undefined, so it has to be greater than 0. There's a vertical asymptote at 0, and we'll go from there. There are no x-intercepts. Nothing makes it 0. There are no y-intercepts either. So if you plug in 0 for x, it's undefined. If I graph this, I do need something. So the end behavior, the denominator is more powerful. So we have end behavior at 0. So we have this, and we have this, and we know what the behavior is at a vertical asymptote and the end behavior, and then we put it together. Number 37. The domain, be careful here. X must be greater than 1, or X must be less than 1, or else you'll get a negative answer in there. The x-intercept, there's none because 0 won't work. Again, with the y-intercept, you can't plug in 0, so there's none there. The end behavior, negative x over the square root of x squared. So we end up with this negative x over positive and negative x. So it's positive and negative 1. Just know that because of the negative x on top, the right is negative 1 and the left is positive 1. All right, let's see if we can put this together. What do we know and how can I fill it in? So I said negative 1 is to the right, positive 1 is here, just like that. We have vertical asymptotes at 1, 2, and negative 1. And so the picture is going to look, remember what the behavior is at the vertical asymptote, and here, again, the behavior and the end behavior, and so that's what the curves are going to look like. 38. Now we have some review questions. For 38, what makes it continuous? So if I plug 2 into the top, and I plug 2 into the bottom and make it equal to each other, I can then solve it. So 4 plus, oops, that's an A. So a couple steps here. Subtract A. Somehow I'll get there. A is a 10/3, right? If you solve it correctly. 39. Use a calculator, I like that, to find the discontinuities. So you can see that x cannot equal 0. I don't need a calculator to tell me that x cannot equal 0. That's where the discontinuity is if you plug in, right? It's not even a line underneath. Number 40. To find the discontinuities here, it's the denominator. So if you only type in the denominator, that's what's going to give you the discontinuities. So what can x not equal? Just the denominator. And so if you press menu algebra, you can actually type in zeros. So what are the zeros of the denominator? X cubed, subtract 2x squared, subtract 2x, plus 4, go comma x. You're finding the zeros for x. And there you go. And round. So negative 1.414 and 2. Just so you know, positive 2, if you plug it on top, is removable. See how positive 2 gives an indeterminate answer? So this one's actually removable, while these two are non-removable, just in case you're asked that question. Number 41 has to do with the intermediate value theorem. So the first function, 41, the intermediate value theorem, it has to be continuous on the interval to begin with. And so before I do anything else, it's not continuous at 0. It's in the middle of the interval, so it does not apply. Why doesn't it apply? And that's in the middle of your interview 42. This is a continuous function, so continuity won't be an issue. So I'm going to plug in -2 and +2. So -2 gives me the answer 6. +2 gives me the answer 2. I want you to know that the answer -1 is not in between. And F at 2. One moment. I'm almost done. (43). Same question, but 5. Now, 5 works because 5 is in between here. So for 43, we can go x squared subtract x equals 5. Oops. And it is in between 2 and 6, so it does work. So subtract 5. And then you'd use a calculator to solve it, honestly. So you'd use a calculator to solve it. So I'm going to go menu, then algebra, then solve. Equals 0. Just make sure that you pick the answer that's in the interval. So the positive answer, 2.791, is the only correct answer. Because it's the only one in the interval, not -1.791, right? Oh no, what's the interval? Between -2, oh sorry, the interval is between -2 and +2, so not this one. That's the other one. It's -1.791. That one is in the interval between -2 and +2. All right, turn the page. We're almost done. 2 more questions. Let's just look at it quick and we're going to be done. Okay, determine an equation for this. Well, this has been shifted how many to the left? So an equation for that is if it's been shifted to the left. Here, I'll do it here. So if you shift to the left, it's x plus 3 squared. And the second one has been shifted up. How many? So you take the parabola up, and it's x squared plus 2. And you're done. All right, Mr. G Math, over and out. I'm proud of you for doing your work. Till next time.